you have taken this one. Okay, so here we have open circuit voltage and we have V maximum. Which is greater, which is smaller? Which is greater, which is smaller? Vm is less than VOC. Yes or no? Why? Because you can see the length here. V maximum is lower value where VOC is higher value. Okay, so VOC is lesser where Vm is lesser where VOC is greater. When you come to the current, which is greater, which is smaller? Im is smaller magnitude and Is is higher magnitude. Okay, how to write down now? Im, what is the relationship between Im and Isc? Im is less than. Okay, so the value of Im is lesser where the value of Isc is greater. Okay, so now you are clear that VOC is the maximum voltage, Isc is the maximum current. But in practical, when you do the test or load test, okay, when you perform the working of the panel under loaded condition, then you will get V maximum and you will get I maximum. Then we are going to define the fill factor like this. This is the ratio covered by the panel Vm into Im. What is Vm into Im? So this is the area covered by the solar panel as Vm into Im. The area covered by maximum voltage and maximum current. Next one divided by the area covered between open circuit voltage and short circuit current. So this will be including this area. Okay, so this will include the remaining area. The red slashed line will indicate. So now black slashed line is having higher area or red slashed line is having higher area? Red one is of higher. Okay, so I am going to say that I am going to divide with VOC into Isc. So it is defined as Vm Im area in the MPPT triangle and VOC into Isc in the given MPPT Vi characteristics. Okay, so now in these two already you are very clear that whether numerator is higher or denominator is higher. Denominator term is higher where numerator term is lower. So since denominator term is higher, automatically you will have a fill factor all the time lower magnitude. Generally the fill factor ranges from 0 to 1. The fill factor ranges from 0 to 1. So that's how to identify the fill factor. If the fill factor is higher, I can say that this solar panel is a good solar panel. If the fill factor is less, I can say that this is a waste solar panel, not as per the standards. Okay, that's how to identify the importance of the solar panel with respect to fill factor. Okay, what is meant by fill factor now? Maximum voltage to the maximum current divided by open circuit voltage into short circuit current. So this fill factor ranges from 0 to 1. This is very important while you study this solar panel. Next one, efficiency of an solar panel. So what is meant by efficiency of an solar panel? So already you know in electrical engineering, efficiency can be defined as output power divided by input power. So I am going to write down it as output power divided by input power. So how to write down the output power? So here what is the output power you can write down? So this Vm into Im is the output of the solar panel. VOC and Isc we never calculate. This is only for nameplate details. So what actually available in the solar panel is Vm into Im. So where Vm into Im, I am going to call it as the power output. Therefore, how to write down the power output? Power output is nothing but VOC into Isc into fill factor divided by what is the input power we are going to give? We don't know the input power. Input power is what? Solar radiation. So this is input power, we are going to call it as power density. Power density. Where this power density I am going to write it as 1000 watt divided by meter square. You know this flux density equal flux per unit area in the case of magnetic field. In the case of here, we are going to call it the input as power density and it is called as irradiation measured as 1000 watt per meter square. So you can see here, this is the units, the numerator units are watts. Automatically the denominator units also should be what? Watts. Then only we can calculate the percentage. But what is creating a disturbance to us? Watt per area. How to nullify this? To convert into watts, you multiply with area of the solar panel. If you multiply with the area of the solar panel, the units of area is meter square. So meter square will get cancelled out, and numerator you have in terms of watts, and denominator also you will be having in terms of watts. Okay, so when you have numerator and denominator in terms of watts, then you can get the efficiency of the solar panel. Generally the efficiency of a solar panel, the maximum is 20 to 25 or 20 to 23. The maximum efficiency of a solar panel ranges from where to where? 20 to 23. More R&D is going on how to increase the efficiency of the solar panel. Okay, so this power density changes upon the temperature. For example, at morning 6 o'clock power density will be 200, at evening 4 o'clock you will have 800, at night at 12 at mid 1 p.m. you will have 1000 watt per meter square. We have an flux measuring meter in our lab. We will measure the power density by using that lab. This is how to calculate the efficiency of an solar panel. So now what are the parameters of a solar panel? Let's try to review the things. What are the parameters of a solar panel? First one is open circuit voltage. Second one is short circuit current. Next one is maximum current of the solar panel. The maximum current that can be developed by the solar panel under a given condition of P maximum or maximum power point. This is the maximum voltage that can be generated by the solar panel under the condition of P maximum. What is meant by fill factor? It defined as the ratio of V maximum divided by VOC into ISC. And next one is the efficiency of an solar panel. What is the efficiency of a solar panel? It is defined as VOC into ISC into fill factor divided by 1000 watt per meter square. Meter square will get cancelled and it will be expressed in percentage. This is called efficiency of an solar panel.